Hi everyone, I'm Mr. Fullerton, and today I'd like to talk to you for a little bit about power. Our goals are going to be to define power and then to calculate the power of a system. So to begin with, what is power? Well, power is the rate at which work is done, and we calculate it. Power is the work done divided by the time it took to do that amount of work. So capital P, power, is work over time. And the units are the units of work over time, or joules per second. A joule per second is also known as a watt. A watt is abbreviated with the capital W. So you've got to be careful. Work is capital W, and the units of power, watts, are capital W. So be very careful as to how you write your units and your formulas. You don't want to mix things up, or you could get things confused very, very easily. Now, it is possible to do the same amount of work but have a different power output if it takes you a different amount of time. Two people doing the same amount of work, the one who does the work faster will have a higher power output, even though the same amount of work was completed. Let's take a look at some examples. Rob and Peter move a sofa 3 meters across the floor by applying a combined force of 200 newtons horizontally. It takes them 6 seconds to move the sofa, so what amount of power did they supply? Well, to do this, we recognize that power is work over time. Work is F cos theta, the force in the direction of the displacement divided by time. Since the cosine of theta, the force and the displacement are in the same direction, cos theta is 0 or 1. So we end up with force, 200 newtons, times the displacement, 3 meters, over the time of 6 seconds, for a grand total of 100 watts of power. Now, same sofa, but Kevin pushes the same sofa 3 meters across the floor by applying a force of 200 newtons. It takes him 12 seconds, however, to move the sofa. What amount of power did Kevin supply? Well, same formula again. Power equals work over time, which is going to be force, cos theta, times d over t, and again cos theta is going to be the cosine of 0 or 1, so that's going to be our force, 200 newtons, 3 meters, our displacement, over 12 seconds, for a total power output of 50 watts. Same amount of work, took him twice as long, so Kevin supplied half the power. One last problem. You can never go wrong with aliens. Alien A lifts a 500 Newton child from the floor to a height of 0.4 meters in 2 seconds. Alien B lifts a 400 Newton student from the floor to a height of 0.5 meters in 1 second. Compared to Alien B, Alien B does what? Well, if Alien A lifts a 500 Newton child from the floor to a height of 0.4 meters in 2 seconds, the power of Alien A is going to be work over time, or force times displacement over time. That's 500 newtons times our displacement, 0.4 meters, in 2 seconds. 500 times 0.4, that's going to give us 200 joules over 2 seconds, or 100 watts. But it did 200 joules of work. Alien B, we can use the same formula, force times displacement over time, did 400 newtons, a displacement of 0.5 meters. Again, that's going to be 200 joules in a time of 1 second. So 200 joules over 1 second is going to be 200 watts. But again, it did 200 joules of work. So in this case, they did the same work, but Alien B develops more power. A nice way to close out our mini lesson on work. Hopefully this was helpful. If you're looking for more information, need more help, check out www.aplusphysics.com. Thanks and have a terrific day.